Hi, welcome to CreepGame Assignment 2.07. Here are the requirements. Because we now can share geometry among many objects, we want to detect and eliminate duplicate geometry in our new CTF scenery. We want to be able to visualize the player somehow, including orientation. We want to implement a fly camera. We want to be able to fly around our scenery to check things out. We want to be able to enable this via the debug menu and also by a button combo to get easier access to the flying ability than using the debug menu. When we're done flying, we want to be able to return back to the player's position, and optionally we want to have the player move to our current position while we're flying. And if that means we wind up, if we're in the air, the player will move to where we are in the air, and then gravity will take over once the flying stops, and we'll fall to the floor, wherever that is below us. And then finally, we want a flag visibility test. We want to have some kind of indicator if the red flag is visible to the red player, which is driven by us. We're going to use multiple points on the flag to test against this, and so that we have some kind of coverage, so that if the flag is visible at all, any one of these points are visible, then we consider the whole flag visible. And we can use the fly camera to test this. Okay, so let's check it out. Let's go to the game. Here's the solution. We'll run the game. Okay, so now you'll notice that the humanoid up on the bridge is missing, just the monsters up there, and that's because I'm using the humanoid for my player character. And I'm going to hit the F key and move backwards, so now you see the player character exactly where I just was, and I can zoom all around him and look at him and look at other stuff in the scene. And if I were to hit the F key, I'd be right back where I had been before. Now if I want to say go up on that bridge using flying, I'll fly up. I'll hit the F key to fly up there, get myself above the bridge, and then hit G, and you'll see that now I'm on the bridge and the guy's not down there. So the flying around we have, that works fine. We see that we've now got an orientation. Right now I'm facing towards the monster, and if I press F, we can see that my character is obviously facing towards the monster thanks to his orientation, his arms showing us his orientation, well, his whole body really. And if I were to move over to the red flag here and then just press G, you'll see that player over there disappear because he'll move to me. There we go. So we have. So now we need to check out the flag visibility, and you'll notice that up here in the upper right-hand side, we've got some stat data, and it says the flag is visible. So let's see what happens if we move down the stairs here. Flag's still visible, still visible. We'll keep moving down. And now there's kind of a wall there, and we move. It's still visible because it's seeing the very bottom point of that flag showing. But if I move a little bit more, you'll see it disappear. So the flag is no longer visible. Okay, so let's check out some code. Let me exit the game. And here is our method to determine whether or not the flag is visible. So previously I had written some code which allowed me to find vertices on the flag model, and I determined that these particular indices were good points to test. These 10 points here were good points to determine visibility against. So the first time this is through, when it's not initialized, what I do is I make up an array of those. I get the verts for each one of those flag indices, and I get the position of that. So I basically make an array of 10 points that I want to test against. So this only happens the first time though, because after that it's initialized. Then what I do is every frame we're going to come into this thing to see if the flag is visible, And I'm going to check all 10 of those points, and what I'll do is make a vector up, and that vector will be from my current position to the current point on the flag. In other words, it'll make a vector drawn from me to the flag, or vice versa, whichever way you want to look at it, and then it passes that vector to this collision tester method that I have, which basically says, find me the nearest wall along this vector, and tell me what distance it is relative to the size of the vector I give you. So what that means is if there's a wall somewhere between me and that flag point, then the distance will come back to be less than 1, because it's less than somewhere in the size of that vector we hit a wall. And if the distance comes back greater than 1, that means there is a wall, but it's beyond the point on the flag. So in other words, it does not obscure the visibility of that point on the flag, and all we have to do is find one point that's visible, and we consider the whole flag visible. So if one point is visible, we return true, but if we try all 10 of them and none are visible, we return false, meaning that the flag is not visible at this particular point. And one other thing, I have a picture that I wrote some code to visualize those points on the flag, and I don't know how well this will show up, but basically I have 10 lines here. There are 4 of them on the pole, and then there are 1, 2, 3, 4 down along the sides of the flag, 1 underneath on the bottom of the flag, and 1 in the very center of the flag. So those points on the flag are the points we're testing against. And that's the conclusion of my overview for CreepGame Assignment 2.07. Thank you and goodbye.